Example 3. Test the series the sum uh, from n equals 1 to infinity of 1 over 2 to the power n minus 1 for convergence or divergence. Solution. We use the limit comparison approach with a sub n equals 1 over 2 to the power n minus 1 and b sub n equals 1 over 2 to the power n. To obtain the limit as n approaches infinity of a sub n over b sub n equals the limit as n approaches infinity of 1 over open 2 to the power n minus 1 close over 1 over 2 to the power n equals the limit as n approaches infinity of 2 to the power n over 2 to the power n minus 1 equals the limit as n approaches infinity of 1 over 1 minus 1 half, over 1 minus 1 over 2 to the power n equals 1 is greater than 0. Since this limit exists and the sum of 1 over 2 to the power n is a convergent geometric series, the given series converges by the limit comparison test. Example 4, determine whether the series, the sum the sum from n equals 1 to infinity of 2n squared plus 3n over the square root of 5 plus n to the, let me restart this. Example 4, determine whether the series, the sum from n equals 1 to infinity of 2n squared plus 3n over the square root of 5 plus n to the 5th power converges or diverges. Solution. The dominant part of the numerator is 2n squared and the dominant part of the denominator is the square root of n to the power 5 equals n 5 over 2, n to the power 5 over 2. This suggests taking a sub n equals 2n squared plus 3n over the square root of 5 plus n to the 5th power, and b sub n equals 2n squared over n to the power 5 over 2 equals 2 over n to the power 1 over 2. The limit as n approaches infinity of a sub n over b sub n equals the limit as n approaches infinity of 2n squared plus 3n over the square root of 5 plus n to the power 5 times n to the power 1 half over 2 equals the limit as n approaches infinity of 2n to the power 5 over 2 plus 3n to the power 3 over 2 over 2 times the square root of 5 plus n to the power 5 equals the limit as n approaches infinity of 2 plus 3 over n over 2 times the square root of 5 over n to the power 5 plus 1 equals 2 plus 0 over 2 times the square root of 0 plus 1 equals 1. Since the sum of b sub n equals 2 times the sum of 1 over n to the power 1 half is divergent, p series with p equals 1 half less than 1, the given series diverges by the limit comparison test. Notice that in testing many series, we find a suitable comparison series, the sum of b sub n, by keeping only the highest powers in the numerator and denominator.